Okay guys, so to continue on our journey of right triangles, we are going to be talking about more special right triangles, right? So we have Pythagorean Theorem, and Pythagorean Theorem helps us figure out the missing sides in a right triangle if we have two sides, okay? So we also learned Pythagorean triples is just a faster way of doing this. And now we're going to go into what we call special right triangles. So the first special right triangle we have is called a 30, 60, 90 triangle. And the reason it's so special is because what it is it's actually just an equilateral triangle that has been cut in half. So keep in mind that this is an equilateral triangle, 60, 60, 60. Okay, so when we're focusing on a 30, 60, 90, keep in mind it's half of an equilateral triangle. That being said, hypothetically, if I was to tell you that this side right here is 5, and I was like, okay guys, find the rest of the sides. Well, using Pythagorean Theorem, it's like I only have one side. I can't find the other two sides. But if we can recall that this is just half of a equilateral triangle, I know then that if this bottom part is 5, then this part, if you folded it, this part would have to be equal, so that's 5. Which means that if it's equilateral and this side is 10, it also means that this side over here has to be 10, and this side over here has to be 10. Well, now I can use what I know, and I have two sides of a triangle, and I can find out what this value is. So I can go through now and I can use Pythagorean theorem. Keep in mind that this actually doesn't exist. I just drew it to show you it's half of an equilateral triangle. So now I can do 5 squared plus x squared is equal to my hypotenuse squared. But of course, I would never do a problem like this. I would first reduce my triangle. So I would actually divide each of those by 5. So I would do 1 squared plus x squared is equal to 2 squared. Once I get my answer, I'm going to multiply it by 5, don't worry. So 1 plus x squared is equal to 4. X squared is equal to 3, and take the square root. So I have x equals positive and negative root 3. Of course, we reject the negative because you can't have a negative side. So the answer is x is the square root of 3. But again, I'm going back to multiply by 5. So my actual x value is 5 root 3. Okay, so keeping in mind that, again, we've worked with similar triangles, what that means is every 30, 60, and that's why it's so special, every 30, 60, 90 triangle has the same proportions as the one above. So again, if I was to do this again, and I told you, for example, that this is 7. Okay, well, if that's 7, then this one over here is 7, and that makes each of the sides of my equilateral triangle 14, right? So this would be 14, yada yada, this would be 7. And then I would have to go through and I would do the same thing. So 7 squared plus x squared is equal to 14 squared. Wait a minute, I wouldn't do that. I would reduce the triangle. So 1 squared plus x squared equals 2 squared. Again, I divided it by 7. And I'm doing the same problem every single time. And so what happens is this ends up being, I can erase the rest of this. And so this ends up being the square root of 3 times 7. So it's 7 root 3. And so on and so on. And so you can start to see the pattern that a 30, 60, 90 triangle gives us. And so what we do then is we simplify this down, and I'll show you again. So again, the side that is across from the 30 degrees, we just name that x. So we say that that's x. And again, because that's x, and if you folded it, that would also be x, making each of the sides 2x. So therefore, the side across from the 90 degrees represents the 2x, okay? And of course, this makes sense. X is the smallest, 2x is the biggest. Then we have our crazy middle child. So across from this 60-degree angle represents my x root 3 side. So every single time in a right 30, 60, 90 right triangle, the ratio of sides are x to x root 3 to 2x. And again, I put this here. Across from the 30 is x, across from the 60 is x root 3, and across from the 90 represents 2x every single time. So when you come across these problems, again, I gave you these 3 problems at the top. I moved the 4. So if you see, they're the exact same problem. It's just I changed where the 4 was. So, and I want you guys to visualize that this is half of an equilateral triangle. So again, if this side is 4, right here, then this side is 4, then the whole bottom is 4. And if the whole bottom is 4, it's fair to say that this side is 2 and this side is 2 as well. And if that's 2, if across from the 30 represents 2, then across from the 60 would have to be 2 root 3. Okay, if you don't believe me, do Pythagorean Theorem. It'll work every single time. Okay, an easier way of doing this, so instead of actually setting up all of this, what you're going to see me start doing is labeling the sides. So across from the 30 is x, across from the 90 is 2x, and across from the 60 is my x root 3 side. And so what I actually do then is I go through and I solve it. So I say x is equal to 2, okay, which means this is 2, which means this is 2 root 3. And so you're going to start to see me solve these equations with these triangles. Okay, once again, across from my 30 is x. So essentially we're finding out what x is, we're finding out what x root 3 is, and we're finding out what 2x is. In this case, they're telling me that the x value is 4, and so this is easy because then I can just plug it in for the rest of it. So 8 and 4 root 3. Okay? Now here, so again, visual, look at this. We don't know how big x is. We don't know how big 2x is. But they're telling me that the x root 3 side is 4. So once again, we don't know x. We know the x root 3 side is 4, and we don't know 2x. So our goal is to take this equation that we have and find out what x is. So if x root 3 is equal to 4, I have to divide by root 3 on both sides. So x is equal to 4 over root 3. But again, we have to rationalize that denominator. So multiply by root 3, and we have 4 root 3 over root 9, which is just 3. Okay, so that's what my x represents, 4 root 3 over 3, which means my 2x has to be 8 root 3 over 3. Okay, again, using what we know to find out, because all 30, 60, 90 triangles are similar. Okay, I'm going to do another one right here. So off to the side, if this is what you want to do, you can put, x is question mark, x root 3 is question mark, and 2x is question mark. Now go over, and again, if you need to put your angles in too, so across from the 30 is x, across from the 60 is this, and across from the 90 is the 2x. And it goes in order, guys. 1x, x root 3, the square root of 3 is like 1.7. So this is 1x, this is 1.7x, and this is 2x. So it does go in order of largest to smallest. But in this case, they're giving me the side across from the 90 is root 3. So they're telling me that this is root 3. Okay, so again, I have to actually take this and solve it. So 2x is equal to root 3, divide by 2, x equals root 3 over 2. Okay, so 1x is equal to root 3 over 2, which means this is equal to root 3 over 2 root 3. And when you have a root by itself, technically it's over 1, guys. So this is actually root 9 over 2, which is 3 over 2. Okay, so you can go ahead and put your missing sides in. You know that the side across from the 30-degree angle is root 3 over 2, and you know the side across from the 60-degree angle is 3 over 2. Okay, filling in those missing sides. The next special right triangle we have is called a 45-45-90 triangle, and this is so special because it is actually half of a square. So every time you have a 45-45-90 triangle, all it is a square kind of cut in half. And so because there's two equal angles, we know that there's two equal sides. Okay, so if that's 3, then this also has to be 3. And then going back to Pythagorean Theorem, let's go ahead and set this up and find my hypotenuse. So 3 squared plus 3 squared is equal to my hypotenuse squared. I would never do this problem. Let's reduce it. 1 squared plus 1 squared is equal to x squared. 1 plus 1 equals x squared. 2 equals x squared. Take the square root, reject the negative. So the square root of 2 is equal to x. Go back and multiply by 3, and my answer is 3 root 2. Okay, let's do the same thing here. Oh, look, I have an isosceles right triangle. If it has 2 equal sides, it has to have 2 equal angles, and this is a 45, 45, 90. Therefore, this is 5. So 5 squared plus 5 squared is equal to my hypotenuse squared. Don't do this problem. 1 squared plus 1 squared is equal to x squared. I just did this problem up there. I know that x ends up being the square root of 2, which means this x is 5 root 2, and so on and so forth. Every 45, 45, 90 has the same proportions, just like the 30, 60, 90 had the same proportions. So every time you come across a 45, 45, 90 triangle, the sides are in the ratios of x, x, and x root 2, okay, every single time. So we're going to try these problems right here. Once again, I see this is a 45, 45, 90 triangle. I know then that these sides have to be the same. So if that's 2 root 3, this has to be 2 root 3. If you want to do Pythagorean Theorem, have fun. But I know that they're in the ratio of x, x, and x root 2. Okay, so that means that this has to be 2 root 3. I literally just took this and put it where this x was. And then don't forget to stick a root 2 on there, which means this side is 2 root 6. Okay, B, again, if you want to draw your little 40 across from the 45 is x, across from the 45 is x, and across from the 90 represents your x root 2. And in this case, they're giving me the side across from the 90, which represents x root 2. So they're telling me x root 2 has to be 5. So we have to solve this. So to solve it, if I have x root 2 equals 5, and some of you guys should be getting good in your head, divide by root 2 on both sides. You have 5 over root 2. Rationalize the denominator, multiply by root 2, multiply by root 2, okay? And so what you end up with is 5 root 2 over 2 is x. So 5 root 2 over 2 and 5 root 2 over 2. These are your missing side lengths of your right triangle. Okay, a couple more. Again, if this is 4, oh look, it's an isosceles right triangle. This has to be 4 and this has to be 4 root 2. Done. If this side is 4, I know that my x root 2 side they're telling me is 4. Therefore, this has to be 4 root 2 over 2. I rationalize really quickly in my head. And I can also simplify this down. So this ends up being 2 root 2. So 2 root 2 and 2 root 2. Okay, we want you guys to get comfortable doing this in your head. Now, again, if you need to pause the video and do it slower, but make sure you guys are able to get the same answers as myself. Okay, if you want to check it using Pythagorean Theorem, because of course we can always use Pythagorean Theorem here, we can call this side x and x. We have x squared plus x squared is equal to 4 squared. 2x squared is equal to 16. X squared is equal to 8. Take the square root of both sides. X is equal to root 4 and root 2, which is 2 root 2, which is what we just figured out using our 45, 45, 90 triangles. Okay, you can reverse the video and watch me do that. But these are called, again, special right triangles. So as of right now, these are some things that you have to have memorized. In a 30, 60, 90 triangle, you need to know that the ratio of sides are x, x root 3, and 2x. In a 45, 45, 90, you need to know they're x, x, x root 2. And you have to know your Pythagorean triples to do things very quickly.